if we're going to talk about heat and heat energy, because we are talking about hydrocarbons in this unit, so think about gasoline, for example. You burn gasoline to make a car go. We have to understand heat transfer. So heat's transferred in three different ways: conduction, convection, and radiation. This is a huge area of study in both chemistry and physics. If you think about things around you that rely on heat transfer or stopping heat transfer, so for example, a thermos in your house, so like a thermos for hot coffee or cold drinks, your car revolves around heat transfer, your hot tub conserves heat transfer. This whole idea of conduction, convection, and radiation are very important. So let's see what these things are. So if you take a spoon and you put it in a glass of hot water, so maybe you got boiling water, after a while the spoon's going to get hot, especially if it's a metal spoon. Why is that? At the microscopic level, as we heat something up, when the temperature increases, the particles move faster and they bounce off each other. Okay, this is conduction. So this transfers all the way up the spoon. So one particle vibrates into the next, vibrates into the next. So this spoon gets hot. This is called a conductor. Now, interestingly enough, if we used a wooden spoon, it wouldn't get hot. Why? Because wood is an insulator, and so are plastics. So they don't have this vibration of molecules occurring at the level that's needed to transfer the heat. Now, how do we stop conduction? We can use things like insulation. So in the walls of your house, the heat would pass right through from conduction until it hits an insulator. Another thing that works is a vacuum. So if we have two walls here and here, and they have air particles in between them, those air particles can bounce off each other and transmit heat. A vacuum is when we suck all the air particles out. If we have no particles to vibrate, we can't have any transfer of energy. So vacuums are insulators. Let's take a look at conduction, or convection. So convection is flow of heat. So, for example, hot air rises, cool air drops, and this can create what's called a convection current. So why does hot air rise? It rises because it becomes less dense as it heats up. The particles move further apart, and then they become more dense and they cool. So if you go to the beach, so there's the sand at the beach, there's the water. When the sun hits the hot sand, sand heats up very quickly. And what happens is that hot air rises. As it rises and starts to cool, it slows down and spreads out. And as it gets over the cooler water, it drops. So on a hot sunny day, hot air will rise above the beach because the beach heats up first. The air slows down, spreads out. When it gets under the cool water, it drops. Now, because all these air particles have left, they create a partial vacuum. So the air comes rushing in to fill the vacuum. This is called a convection current. So when you think of convection, think of hot air or water rising and cooler air or water dropping, creating this loop or current that occurs. How do we stop heat loss by convection? Well, we can put seals around doors or caulking on windows. All of these things stop the loss of energy through flow. Now, the last way that heat is transferred is through radiation. You guys are getting a real art lesson today. There's the Earth and there's the Sun. Outer space has very few particles in it, so heat can't transfer through conduction because we said we need particles. Remember, space is like negative 270 degrees Celsius. It's really super cold because we need to have particles to have temperature. There is a form of heat that can transfer in the absence of particles, and that's called radiation. So light travels in the form of waves. So this is wave energy. I'm sure you've heard about this before in science, but there's different types of wave energy. So there's like microwaves and gamma rays and infrared rays and ultraviolet, and we've got radio waves. Very little of the wave energy is visible light, but Roy G. Biv, red, orange, yellow, Roy G. green, blue, indigo, violet, are part of this radiation that comes through. So radiation is a form of energy that can travel in the absence of particles. Okay, and it literally does travel in waves. What do we do to stop? What do we do to stop the loss of radiant energy? Well, shiny surfaces. So aluminum foil will reflect the radiant energy. So let's take a look at something that is designed so that it won't lose that it won't lose heat energy. If you go up into any new buildings in your area, like houses, you'll notice ways that houses are made so that they don't lose energy. Insulation in the walls and up in the ceiling to stop conduction. They will have airtight windows and doors to stop convection. And if there's new construction going on in your area, look at the outside of the houses. Now with the insulation they're putting shiny backing on it. So if the houses are at a certain place in their process of being constructed, you will see that shiny surface. I live in Paris, Ontario, and I see this all the time as we get new buildings going up. This shiny surface does two things. It keeps the heat in the winter, and it keeps the sunlight out in the summer, because remember, shiny surfaces will reflect. Let's take a look at a couple other things. Let's take a look at a campfire. More great drawings by Mr. Parsons. Here we go. We got a campfire. Okay, so just to get the idea of this radiant energy, you can understand why it's hot up above a fire, because hot air rises. So we said that with convection. How come if you're standing beside the fire it feels hot? Because it has to come at you, it has to have a way of transferring to you. This fire will give off radiant energy. Okay? So energy is transferred, transformed in many different ways. Conduction, convection, radiation. Remember the ways to stop that transfer of energy. Conduction, insulation or vacuums. Convection, blocking up holes so things can't seep through, and radiation, using shiny surfaces.